Okay, so thanks for hanging in there. And I was beginning to think, uh-oh, what am I going to do now? Hopefully you can see everything. Let me get I don't have a chat pulled up here, just in case you put something in that. Okay, there we go. I'll show that over there. Okay, so as I was saying, we're going to do some things with functions. But before you can really talk about functions, and many of you probably had, some of this is going to be kind of review for you, I believe, because I think you're going to have seen this before. Okay, but I'm going to make some assumptions that maybe you haven't. Okay, I'm trying to get my other computer rolling here. But before we can talk about functions, we got to talk about relations. Okay, and so in mathematics, basically algebra, you have relations and then you have functions. And basically, just a relation is a correspondence between two quantities. And normally those quantities are x and y, right? I mean, that's what we usually see. Equations and functions are usually in terms of an x and a y, right? So, but these relations, all right, are just this correspondence. So if, for example, a job that earns a wage is a perfect example of that. So if you're on an hourly wage, then you know that for every hour that you are working, you're making money, right? So if that's your situation, then that's how that works, and that's a relation. So time, money, right? If we have if you take a package and you mail it, all right, you know that the size and the weight of the package is going to probably determine the cost of the package. Parking, the time that you park is, the cost is related to that. Okay, so there's a lot of different things that are relations. It's just a correspondence, all right? And a lot of times you'll see stuff like this. They'll draw these little like bean-shaped things, right? And they'll do this. This is kind of a math thing. You see this, okay? And then they draw arrows. Oh yeah, it's called a mapping. So 1 goes to 8, and 2 goes to 9, and 3 goes to 10, and 4 goes to 12. Okay, so that's what that is. But inside the relations are functions. And that's what you spend most of your, well, at this level of mathematics is spent on functions. Okay, so we talk a ton about functions. So functions are just relations such that for each element in the domain, I'm going to write down here. And then in parentheses, I'm going to put input. There is only one element in the range, which in parentheses I'm going to put output. Okay, so what does that mean? Well, so in a relation, obviously, we talked about how I said, well, if you're earning minimum a wage, right, based on an hour, and you work 1, 2, 3, 4, 5 hours, you're making more money. Well, the amount of time that you're putting in is, excuse me, is the input, okay? So you're putting time in and then you're getting money out, right? That's how it kind of works. So the input is called a domain and the output is called a range. I am almost with you here completely. So if we did a little, there we go, little mapping diagram here. 1, 2, 3, 4, 8, 9, 10, 11. Then 1 goes to 8, 2 goes to 9, 3 goes to 10, 4 goes to 11. So this is a domain. And this is the range. So the domain is the input, and the range is the output. No, you will not need a graphing calculator. You can use one, but I want to show you how to use Desmos tonight, and that will be what you will need. And the best part about that is it's free. Okay. So the function, again, the domain is your input, range is your output. All right. So that's an example of one. Okay, so let me do another one here. And I'm just kind of doing some number stuff right now. And later we'll kind of broaden it out a little bit. So this one's going to go here, 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 and here. So again, this is your input. So this is a domain. And this is your output. This is the range. All right. And the rule is the function. So in other words, what is happening to the domain numbers that's giving us the range numbers, right? That's the rule. That's the function. So here we're taking, and some of you probably see this, right? 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So we would say that it's getting squared, okay, or x squared, where this is x and this is y, right? So that's what's happening. They're getting squared, all right? So this would be the function, right? It's the rule, domain, range, input, output. That's how it works. Okay? That's how it works. Now, does that mean anything I put here is going to be a function? Well, let's take a look at these. So let's say I have 1, 2, 3, 4. You can see I'm real original, right? 5, 5, 5, 5. This one goes here. This one goes here. This one goes here. This one goes here. Okay, so our definition said that for every element in this domain, then there's one element and only one in the range. Well, this 1 goes to 5, and this 2 also goes to 5, and this 3 goes to 5, and this 4 goes to 5. So the answer is, it is, because this 1 goes to a 5. Now, they all go to 5, right? But it doesn't make any difference. As long as it just goes to one number, we're okay. It's what happens when it goes to 2 numbers. So if, again, I'm drawing a lot of these, right? If I switch it up a little bit, now let's say I go, this time I'm going to go 8, 9, 10, and 11. And here, this is going to go to here. 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 And oh, by the way, that goes there too. All right. So in this case, this is not a function because right here, this 4 goes to 2 things. Can't happen. That doesn't make sense. It doesn't work. All right. So that's not a function. Okay. So I'll give you a couple seconds to write that down. I want to get my other computer to join a class here. I'm really glad you guys hung in there. That's awesome because I was concerned.
So just a question.
Yeah.
The one that goes 1, 2, 3, 4 on one side and then all fives on the other side, that one is a function, correct?
Yeah, because
Okay.
every number in the domain only has one number. Sure, they're all the same, but it still only has that one number.
Thank you.
Okay. So now that we kind of got a little bit of a gut feeling, let's think about this for a minute. Let's throw numbers out the door for a little bit and let's just talk about certain situations. So I already said something about, well, what if you had, parking, for example, right? And we have hours here, okay, and the cost here. And, I can remember, let's say a smart park situation, right? So, as a smart park situation, here's your domain, here's your range, by the way. Is that a function for all different hours? What do you think?
Yes, it's a function.
Okay. So, yes, it is. Okay, I'm getting a couple of people saying yes. All right, good. Because how does it work exactly? So when we go to a smart park and we park for an hour versus parking for an hour and 30 minutes, what is our cost going to be for that? How does that work? Anybody want to chime in on that?
So each hour is going to have a different cost associated to it.
Good.
So it'll have a rate to it.
Okay. So what about, I have somebody here that says no. This is kind of interesting. So what if I park for an hour and a half, right? Or an hour and 5 minutes? Is that the same cost as an hour?
It is the same cost, but wouldn't it be like your example of having all fives? So you might fall within a window of a certain cost, but it still has its own price associated with that timestamp.
Okay. So I still have, if I have an hour, I'm good, I have a cost. If I have an hour and 5 minutes, I have a cost, right? In other words, they can't charge me two different things for an hour and 5 minutes. Now, Joe here says no, too many hours per cost. Can you kind of elaborate a little bit on that? Would you feel comfortable in telling me kind of what your thinking is there? I'm interested. Or maybe even just provide us with an example. And you can throw it in the chat too if you want.
Are you thinking maybe in terms of days of the week versus the weekend and prime parking versus carpool parking?
Thinking along the lines of 1 over an hour rounds to 2. Right. Sorry, poor Joe's breaking up here. So, yeah, it could be. I don't know. But you should still, if you have a certain amount of time there, they can't charge you two different rates. And I think that's the key, right? That it could be the same cost, because it could round to 2, as Sean says, right? But that's okay, because if 1.5 or 1 hour and 5 minutes rounds to 2, even though you're getting charged the same, it's just going to one amount. All right, so that's good. What about this one? What about people? Let's say we have people and phone numbers. Okay, would that be a function? People and phone numbers. What do we think?
I don't think it's a function.
So I'm getting a lot of yeses here. Sean says only if they have one phone number. Aha. So I kind of proposed this once and to my high school students, and that's what they told me, Irene, is that they said, well, we can have a couple different phone numbers. Okay, so if that's the case, then that wouldn't be a function, right? Because if you have 2 different phone numbers, then you're the input and the phone numbers are the output. That's not a function. It's got to be a one output per input. Okay, good thinking. Trying to think of another one. What about your obviously this one, yourself and emails. What about that? No. Yeah. Right. We have multiple email addresses probably. Yeah. I like it. We're catching on to this. Okay. Yeah. Good job. So that's kind of how functions work. Okay. I'm just going back here. I'm going to take a look at. I want to make sure I cover everything that in this that you got to do. And this is I forgot to tell you, by the way, this is like in the 50s, if you want to follow along here. Let's see, I kind of did that part for you. They sometimes have a situation like this. They'll give you little brackets here, and they'll put ordered pairs in here. Okay, and the question is going to be, is this a function? And if so, state domain and range. Okay. Now we have to be careful with this one because I've seen things like this on quizzes and people get these wrong. So first of all, are we good with this being a function? What do we think? I get a couple yeses. This is a great group. You guys are participating. This is awesome. Okay. Yes, I would agree with that. We definitely have a function here. What about the domain? What's that? Very good. Very good. Okay. Yeah, you're right. All right. So 2, 3, 4, 5. Now, oftentimes, I'll put this on a quiz, and the response to the domain is 2 through 5. No, it doesn't contain the numbers 2 through 5. It's only 2, 3, 4, and 5. They're distinct or discrete numbers. Okay, so you don't want to say, oh, it's just 2 through 5. Careful with that. Range, obviously, what's that going to be? Yeah, cool. We're getting it. 5, 8, 11, and 14. Okay. So you will see functions defined as ordered pairs, and they have that in our assignment. The next part is probably the hardest one, and Oh, I like, yeah. So you're defining that, Irene. Let's see. X comma Y, domain range. I think how you communicate to me your domain or range is kind of a preference. One of the things that I've noticed in teaching this class is that somewhere you got slammed a lot with interval notation. And I get a lot of people who write things in interval notation or the set builder notation. They go, X such that and whatever. Hey, if that's something that and you can communicate to me, that's fine. I'm not one that's going to say, this is the only way to do this problem, or this is the only way to give me the answer. I'm not like that. So if you can communicate to me like this, okay, you want to use, uh, instead of listing them out, you want to use some set builder or whatever, that's fine. If you said the first number and the second number, I probably would be a little more particular about that. I'd rather you tell me what the numbers are rather than say first number and second number. But I understand what you're saying. Okay. So let me show you. I'm going to load up here real quick. Somebody asked me about GeoGebra, and I'm going to put that up here. And I'm hoping that this is going to help, because the whole idea of a domain and a range is tough when it's not in that format. So I'm going to go ahead and, where's my, am I not? Oh, okay. Let me stop this share and go to this share. There it is. Minimize this guy. Close that down. There we go. Okay. And excuse me for just a second here.
Can I ask you something real fast?
Yeah, you can. You can ask me what. No problem. Ask away.
Desmos on my phone. Should I put it on my computer too? I always find it easier on my phone when I'm looking at the computer with my questions, but I'm not sure if it works differently.
Yeah, Steffi, I tell my students to have it on their phone. That way they can look at the screen, the computer screen, or whatever they're looking at, and have it on their phone instead of kind of, tabbing back and forth. I think it's easier personally, but again, that's a preference thing. So whatever you want to do there. So what I'm going to do is I put in this function here, and I didn't mean to put that point in there. I want to get rid of that guy. I'm going to draw a line down here. Oops. There we go. Sweet. Okay. So I'm going to go ahead, and I got a perpendicular line drawn down, and I have this screen here. Okay, and most of you know this as being a parabola. All right. But I'm going to go ahead and I'm going to do a little bit of work here. Oh, I went too far. There we go. I like that better. No. Oh, okay, gotcha. There we go. Okay, let's see if it works. Beautiful. All right, let me put a point on here. See if it brings it back. Good. Now, this is going to show you a little bit about domain and range, and I haven't done this before. I just kind of created it today. All right, so what I'm going to do is come down here, and I'm going to trace this, and I'm going to kind of show you what the domain does. So domain starts right about here, okay, right there at, should be -3, and as we come down, okay, I'm going to come down kind of slowly here. You can see it's kind of tracing some numbers on the x-axis there. It's a little jumpy, but not too bad. All right, until it goes to right about there. So these numbers are in the domain of that. All right, in this case, it is all the numbers between about -3 to 3. Okay. So this would be the domain. Okay, and it is nice and smooth, all the numbers between that curve. If this was endless, in other words, I took these brackets away. I put the brackets on there to restrict it. So now let's say I take the brackets away, and I go like, why is it doing that? I'll fix you. Let me get rid of this. Maybe I'll fix you. Okay, now let me trace this again. As I move this, come on, I just wanted to trace that. Let's see if it does it again. There it goes. Okay, and it's a little jumpy. But if I keep going and going and going and going, and it's going to keep going, right? It doesn't just stop there. And same thing on this side. And if I continue to just keep following that curve, eventually all these numbers are going to get filled up on this X number line. And that's your domain. And in that case, the domain would be all real numbers. Okay? Yeah, domain is input, right? Domain is your input and the range is your output. Sorry, I just noticed that. So I thought this was a pretty good way of explaining how domain works on a graph, just by looking at it in GeoGebra and bringing this line down so you can see it. Range is the same thing. However, in the assignment, they don't talk a lot about the range. I don't believe so when I was looking at that. No, they didn't. It's just domain. So when we do, oops. So the range they don't talk too much about. And I could do the same thing and draw a perpendicular line straight across here and trace on the y-axis, and you would see that that would be the range. Okay. So when we are taking a look at, and let me just show you real quick here what Desmos looks like. Okay, I gotta move this out of the way. I'm gonna open this up. And I'm just going to click on Desmos right here. DESMOS is what you want to look at. Okay. DESMOS. And when you click on Desmos, and you can either, like I said, download it. We want the graphing calculator, by the way. Now your phone's going to look a little different than what this does. I'm sorry about this junk. But it's pretty much the same thing. You're going to probably have this guy. It might be a little bit different as far as how it's arranged. And if you've never done anything in Desmos before, all right, it's really awesome. And it uses a calculator, so you can put numbers in here, and it will figure out what the calculation is, just like that. Okay, you don't have to put equals. You can just type stuff in, and it does it. Okay, so not only does it graph stuff, but it's also a great calculator. It does square roots, okay, all your basic operations here, your powers, you can do that, absolute value. Here's functions, it has all kinds of stuff in here. All right, it's pretty simple to use, that's why I like it. And to graph stuff, I'm just going to type y equals. You don't really need to type y equals, but you can. I'm just going to put another little parabola back in there, okay? And to show you how that, to talk about the domain of that. Now I can't put a point on here and move it around and slide it down onto this thing, so you can't see that. But when you have a graph and you want to say, okay, what's the domain of this? So you want to take that curve and think about bending it down onto the x-axis, okay? So this curve, if we bent it down onto the x-axis, would cover all the numbers, right? It's just like I did have that point, and I could slide a point there, and I could draw it down. If I keep going in either direction, I'm eventually going to cover that whole x-axis. So the domain of this would be, we'd say all real numbers, okay? Sorry. All right. So that's how Desmos kind of works. Let me show you another couple of ones here. I want to get rid of this one and type in y equals square root x minus 2. Okay. Now here, right, I can slide a point. Now what I'm using my mouse, but if you're using your phone, you can just use your finger, and it should have a point with the coordinates that show as you go along there. All right, it should do that. Again, here, this is your domain, but it starts here. All right, it doesn't go in. That's where it starts. So I can't go back any further. If I was to put a point on here, okay, and had it draw perpendicular lines, it would start there at that 2. All right, so in this case, we would say the domain is greater than or equal to 2. All right, so we would say that that's greater than or equal to 2. All right. And there's a lot of different functions we can put in and investigate. Those ones are going to start and stop. Let's see if I have another one I can do. We could do this one. We'll put a third in here. All right, so here again, all right, if I took this curve, which kind of looks like this, sort of, all right, and I folded this half up and this half down, all right, or if you think about that point that goes straight up to there, then you can see that that's going to be all real numbers for that too. Now we're just talking domain here, right? Just the x. Any questions on using, is everybody being able to use Desmos okay? Are we doing all right on that? Sweet. Good. Yeah, I mean, it's a great tool. A lot of you guys are saying yeah and yes, and that's great. So you probably have, yeah, you'll get a lot more practice. Don't worry about that. So you just, it's, again, you're just typing stuff in, y equals, and then x, and then you can put in a number of different things, okay, whatever it is. And then just doing basic calculations, it's really good. All right, first time, okay. Well, hopefully it's working out. And again, you can access the online version, or it's a free app. You can download it. And you can even create an account, and accounts are free. And the nice thing about that is it saves your stuff. All right, so like I have an account, and I got all kinds of stuff saved. So yeah, you can, let me see, you're saying you want a table. Yeah, you can get a table. You're right. Mm-hmm. There we go. Yeah, there's a lot of stuff to it. That's cool. Yeah. Oh, yeah, it is. It is cool, and it's like I say, it's free, which makes it cooler. So, um, let me see. I don't really have. Is there any? Do you have any questions about finding domains with graphs and using Desmos to help with that? If you do, just please ask.
I have a question.
Yeah.
So, if the first graph that you drew, the lines didn't go on forever, and so that, just double checking, that domain was all of the numbers that fit. I think it was between like -3 and 3. But for these last couple that you've drawn, the curve, the lines went up on forever, so it's all real numbers. And then the last one you drew, or the second to last one you drew, where it started at, I forget what it started at. I drew mine starting at 1 and then going up and over to the right. Then everything under that line that falls on the x-axis is our domain. Correct?
Yes, and I'm glad you brought that up because the first one I did, I restricted it from -3 to 3. And in actuality, I made it so that it didn't really contain -3. So there's a little hole there, open dot at -3 and 3. So what we would do is we would say the domain is -3, all real numbers between -3 and 3. Now, again, how you write that is up to you. So I have seen this sort of notation. I have seen notation where, let's see, interval notation like this. So in this case, it would be a -3 to 3 with parentheses. X such that -3 to 3. You can write it out if you want to. -3 to 3, if that's what you want to do. So I've seen that in a number of different spots. The other ones that I did, well, not.
Oh, can you show or share your tablet?
Oh, sorry. No,
you're okay. Thank you.
No, thanks for telling me. There we go. So, yeah, so what I was saying is that in that first one where I had those open circles, -3 to 3, you can write it like this, okay? Interval notation, something like this. If we had it so it was equal to -3 and 3, then I would just put my inequality signs underneath here and then put brackets in interval notation. Okay. So if we had one where it went on like this, then I would just simply say the domain is all real. Okay. But again, I've seen people say, well, that's -infinity to infinity. Okay, if that's what you want to say, that's fine. I understand that. It really kind of depends on what your background is and what you're comfortable in.
Thank you.
Oh, you're welcome. So that's the stuff with domains. I think you'll be able to do, I don't see, let's see. Gosh. I think you're okay. There might have been, and I don't have my syllabus thing handy, but I think I kind of stayed away from some of the rational ones, I believe. They do give you some functions and want you to evaluate them. They don't call it evaluate, but that's really what you're doing. So they say, all right, let's say you have a function, and this is the notation for it. We haven't really done much with that. 2x squared plus x minus 1. And so they want you to find f of 1 f of -1, f of 0, and even something like f of just a negative x like that. So they're going to give you some stuff like that to work on. Well, really all you're doing is sticking in these numbers in for wherever you see an x. So a function is titled usually by using a single letter. It can be f, most commonly g, j, h, k, whatever you want to put there. It doesn't make any difference. The x variable here is always going to be what is used in the actual rule or equation. Okay? So whatever this is, and it could be a t if you were doing something in physics and it would be based upon time, then you might have h of t or something like that. Okay? So whatever variable is used here is going to be used throughout. So f of 1 then, what I would do is I would just go like this. Okay, so wherever I see an x, I'm going to put a 1. And see how I kind of made it in parentheses. And then I would just figure this out. Now, here, you can use decimals, right, if you want to. And you could simply, and I can show you quickly here. Let me stop this real quick. There's a couple ways, actually, and it's pretty slick. Get rid of that. So you could simply just go like this. Okay, I'm going to go 2 times. Now, if we're just doing 1, we can just go 1 squared. I think I forgot what. I think it's -1 I had. Plus, is that what I had for an equation? I don't remember what it was. Was it 2x squared minus x plus 1? Yeah. Okay, thanks. So I could do that, right? You could.
No, it was 2x squared plus x minus 1.
Plus x, okay. Well, I kind of got it right here. Oops. Thank you. -1. There we go. I could go like this and actually define it and put it in here. And then come down here and say, hey, Desmos, can you figure that out for me? And just go f parentheses 1. And see, it does it for you. It sticks it in there. All right. I mean, you know, if you had a lot to do there, that would work. All right. So, for example, let's do the one where I put a -1 in there. Okay. So now I'm going to change this to a -1. Oh, now I get 0. All right. Now I get 0. And see how it kind of graphs it too? So that's kind of nice, right? So there's -1. And there's, you can just about get to 1. Okay, you can almost get to the 1. Now, it's worth mentioning here, what's happening is, let me see if I can annotate this. All right. That what it does with this -1 is it's putting it in there. So this is going to be 2 times -1, sorry for the parentheses there, squared -1 minus 1. And I put that parentheses because if I don't, then it's going to treat this a little bit differently. So I go -1 squared, following order of operations. -1 squared is positive, so that would be 2 minus 1 minus 1. You can see where that's going to give you 0, right? If you don't put it in parentheses, then what it might do is do this, is go, oh, then square it, sorry, like this, okay? It'd take 1, square it, and then make it negative. So that means you would have a -2 here. -1 minus 1 gives you a -4, and that's different. All right, so hopefully you kind of see that. You want to put negatives in parentheses because you're telling it you want to square the number first and then do whatever you want to do to it. Whereas here, right here, let me put this in purple for a second. Right here, you're saying, I'm going to take 1, square it, make it negative, which changes the problem a little bit. Okay. All right, good. For the f of x, let me stop. We can't. Unfortunately, Desmos won't do that part. Let me move this. Let me get rid of this and stop this. So over here, if we're going to do this negative x, then what we do is we put a negative x wherever we have a x. So this is going to be negative x. See, here's a perfect example of that. So then I'm going to take negative x and square it. Well, a negative times a negative makes it a positive, so that's going to be 2x squared, right, minus x minus 1. Well, I can't do anything more with that, so I just leave it. Okay, I'm just going to leave that. So I have a couple of those for you to look at. Let's see. Hang in there for just a little bit longer here. The other thing they have you do is add. And I want to talk about this for a second. So let's say we have two functions. Go back to this one again. Okay. And we want to add those. Well, it's not difficult to add them. It's just the way that it's written. Okay. When I kind of prefer this notation, because to me, this is telling me what I'm supposed to do with these two things. I'm supposed to add them. This one is not always clear as to what they want us to do. I kind of like this one better. So I'll try to give both of them on tests and quizzes, but I probably lean a little more to that one just because I think it's easier for students to understand. And all I'm going to do here is add these things. So I'm just going to go like this plus this. And then I should add them up. All right, so 2x squared, 3x, 1x, that gives me 4x. Negative 5 minus 1 gives me a negative 6. Okay. And if you subtract them, then you're going to subtract them. No, it's not a system. A systems of equations, you would have two, and you're looking to see where they cross and meet. It's just a couple of functions. I can see where you would think that. I guess, in a sense, it might be, but it's not quite in that context, if that makes sense. So here I'm going to subtract this. I don't have any squares in the first function, so I'm just going to make it 2x squared. Here I'm going to go like this. I'm going to take 3x minus x. That gives me a 2x. And here I'm going to take a negative 5 and add 1 and get a negative 4. Okay. Oh, this has got to be a negative. All right. If you see f of x times g of x, or f of and g and x like this, then you're going to multiply them. Right, in that case, you're just going to FOIL. And you're probably really good at foiling because most students are. That's a cube, by the way. Just make sure that you kind of carry it out. And let's see, we got that one and that one. That's a negative 7, negative 8, and plus 5. Right. as far as division goes, I don't know if I gave you any divisions. I don't think I did. If I gave you divisions, don't divide them. Just leave them as one over the other. Okay. I think that's all the ones that I really had for that section. Is there any questions on anything that we've done there? I know it's been kind of long and it's hot and you're probably ready to quit listening to me and
So when it asks us to evaluate a function, it's just basically asking to make sure that there's no like domains that go to multiple input or outputs. I mean,
to evaluate a function that
make sure that it's like a real function and not like the example you showed earlier where the x went to two y's.
So usually when you see evaluate, are you looking at a particular one or are you just asking me something in general here?
I'm just looking at like the homework pages. It's just saying like evaluate
Okay.
the functions, right?
Which page is that?
56 in the textbook.
Okay, let me go back to it here. I want to look at it.
Or maybe it was section 1.2 that I was looking at.
Okay, because yeah, I'm looking. I don't see evaluates here.
Or what? Oh, I guess then can you explain just what you mean when you write evaluate?
Yeah. So evaluate, basically, you're going to get a function, or two or three, depends. But let's say we get one, say something like this, all right? And they're going to give you a number usually. So then in that case, you would stick that number into this function since it's f. They're both f's.
Oh, so you're just like solving for the x that it gives us.
Yeah, so you're just basically putting that inside there.
All right, that makes sense.
Okay. Like that. Other good questions? Okay, I want to try.
Just about Pearson in general.
Oh, I'll try.
I'm just wondering, do they have like an answer key to make sure that we're getting our answers right, so we're not learning something incorrectly before we can ask you questions about it?
I think they do actually. It's in the A section. So I think if you go to like A3, there's like a little page box that you can change, at least I can. And I think if you go to A something, it will give you the answers. I don't know if it does for every single one, but it does to most of them.
I just saw that there's a tab that says answers, so I think that's
okay.
So, thank you.
Yep. The thing here, let's spend a little bit of time on too, and then we can spend some more on it on Wednesday because you've been here a long time. So I'm just trying to zip through to the assignment part here. Basically, what they're gonna do is give you some. They're going to talk about domain and range and intercepts and symmetry, and then they're going to give you a lot of questions about a certain function. Okay. So what I'm going to do is, let's do this real quick here. Let me give you a graph. Okay, and I'm going to draw an equation on here. Let's just draw something that looks like this. Okay. So again, if I put a point on here and I run it along this graph, and I think about that perpendicular line that's coming down, right? And I slide it along there, it's going to cover everything. Okay. And also, this is a function. because this point, if I zoomed in on that particular point, it has an x value and a corresponding y value. And the same thing here, and the same thing here, and the same thing here. Okay, they don't have 2, they have 1. So that makes this a function. All right. Now it's easy to figure out if a graph is a function or not. Because if I change this a little bit and I make it look like this now, that is not a function, because look what happens right here at this point. This has an x value and the corresponding y is here, but also it has an x value and the corresponding y is there. So it has 2 corresponding y values, right? So as Stephanie says, that's not a function. But there's an easy way to figure that out. And some of you have probably heard of that vertical line test, right? And so it basically just says that if you can pass a vertical line, a function, now let's see. So if a vertical line crosses a graph of a relation in 2 or more points, spots, whatever you want to say there, it is not a function. So for a lot of people, they can visually see that if I draw a vertical line through there, it hits here, it's not a function. This is not a function. Okay? All right, that's called a vertical line test. You've probably heard of that because you've seen it in other mathematics courses somewhere. All right, so that's not a function. All right. And that opens things up for us because now we can graph anything we want in Desmos and check and see if it passes the vertical line test. It's hard to draw a vertical line and move it around. You kind of can in Desmos, but I think it's just kind of visually look at it and inspect it and check to see if it has passes the vertical line. So one of the first questions that you have in 1.2 is, tell me the domain and range, and are these functions? Okay, so you got to use a vertical line test to check to see and see if they are. The other thing they talk about is intercepts. And to be really straight and honest with you, the only intercepts that really matter, except for lines, is the x-intercepts. Now, this text is big on the y-intercept, which really isn't that important when it comes to non-linear graphs. In a line graph, I would say, yep, you bet, that is pretty important. And I guess in an exponential kind of is too. But really, in some of these other ones, the y-intercept just isn't that important. So on a quiz or a test, I'm not going to ask you about the y-intercepts. I'm super interested in these guys, though. So let's take a look in Desmos real quick, how to do that. So I'm just going to drop into Desmos here from my tablet, maybe. And then we'll finish up. And I'll put one in here, and I'm going to show you how to find the x-intercepts. All right. This will be the last thing we'll do here. And they'll be able to get through most of the assignment in 1.2. Move this out of the way. Okay. So let's say I put this in. So I'm going to go 0.2. I'm going to put it in this form here because it's easier for me to give you an example.
Switch your screen sharing to Desmos.
Ah, gosh, you're right. I keep forgetting that. Dang thing.
No worries, thank you.
Where is it? Hang on. No, not that. There we go. Screen sharing, come on. Got it. Okay, so then let me put this guy in here. Just go there. There we go. Okay, so here, let me close that up. If you didn't see it, I can write it out for you, I guess. Let me see. I don't know why I'm not getting more. Oh, there we go. Annotate. Oops. So that's kind of what I put in there. Now to find the zeros, it's easy. So once you graph that in, all right, you just tap right on the x-intercept right there. Okay, tap and tap. So it tells you what the y-intercept is also, but again, I'm not as interested in that one, but I am on the x's. So when they give you an equation and you just need to find the x-intercepts, you put it in Desmos and graph it and then tap where it crosses the x-axis because those are your x-intercepts. All right? It's that easy. All right? That's how you do that. Okay. If they give you a graph, then just look where it crosses the x-axis, and those would be your x-intercepts. All right. And x-intercepts and zeros are the same thing. Okay, so if they ask you for zeros, then the x-intercept and the zeros are the same thing. All right. I really think that's a lot of stuff. I think you'll be okay. And if not, you'll ask me some questions and we can do some more of 1.2 on Wednesday. So I'm not too concerned about that. Okay. Do you want me to do another one with x-intercepts, or are we okay with that? Sweet. All right. Hey, I really appreciate you hanging out through the little glitch we had there. I was kind of concerned again that I thought, oh man, first day, here's what we got going on. They're going to think what's going on with this guy. But thanks for hanging in there. I hope that you can cool off a little bit, and we'll see you on Wednesday. If you have questions about anything, please feel free to ask me. Again, I recorded this, so